All right, so I'm here under Figure 1 Tech 5, and you'll see it's called a fission product yield curve. All right, so what I'm going to do is I'm going to draw this picture of a fission event occurring once again, a neutron interacting with our target uranium-235. And then we said, generally, I would get, most likely, 2 fission fragments, right, like this. And generally, 2 neutrons. Well, what are these fission fragments? What elements and what isotopes of those elements? That is defined because these are called fission products or fission fragments. They were born from the uranium splitting. They got to be something. That's where this graph comes in. This graph. This here is called the fission yield, and it's in percentage. So it essentially represents the probability that a certain isotope is going to be created. What's very important is look at this. This is mass number on the bottom. Mass number. So then we draw the graph itself, and we see that there is a very high probability that, and this is mass number, so recognize it starts way down here, 70, and I'm going way up here, 160. So right about here, a mass number of 95, there's a high probability, right? This is not the atomic number, this is the mass number, total number of protons and neutrons. And there's also a high probability here, and all the way around there, there's high probabilities of all of these isotopes. This is the probability that these fission products will be created. There's a high probability if you have a mass number of 95 or a mass number around 139, that's where these two are, these two peaks, high probability you're going to be created. So if you were to look around those mass numbers and all of the isotopes that could have those mass numbers, all of the atomic numbers that could have those mass numbers, you're going to find a whole group of elements that can be created as fission fragments, and all those elements can have different number of neutrons. Therefore, there'll be different numbers of isotopes. So this is going to be very important. We're going to find out that some very important fission fragments that cause some operational concerns. One of the most important is going to be tellurium, which decays to iodine, which decays to xenon. And xenon is a huge operational concern. Another one, we're going to see neodymium. It decays to promethium, which decays to samarium, another operational concern. Very key. And we're going to find out that they end up here being high probabilities of being created, both the parent and the daughters that kick it out. So this will be real important as we go forward. Now, when we talk about fission product yield, remember the symbol. This would be fission product yield for, say, tellurium. So I put a little T and a little E here. That would be the probability that tellurium is going to get created as one of the fission products. That would be its fission product yield and percentage. All right, very good.